Hello, good afternoon. This is the NeMo Hackathon webinar. Welcome. My name is Andrew Winder. I'm from Etico ITS Europe in Brussels. We are the dissemination manager for the NeMo project. I think you all know a bit about what the project is, so I'll go very quickly just through the purpose and the agenda. So we're launching a hackathon in the final year of our project to come up with new ideas and apps and other services for promoting electromobility deployment using the different services on the NeMo hypernetwork that we've developed. These include open tools, the hypernetwork itself, and the services that are on it, and common information models. The hypernetwork is a distributed system based on blockchain, so it's not open to everyone at the moment. It requires a login, but this first stage we are looking just for ideas and expressions of interest, so it will be offline, and that will be by the 3rd of April. We're asking for a first idea. Then we'll select some finalists, 3 finalists, and these people will develop services on the hypernetwork to which they will be given access. And then we'll have a presentation at the ITS European Congress in the Netherlands in June for those who have developed a successful service and who are able to come. And then the winner we will invite and pay their expenses to come to our final event, which will be in Barcelona on 18th of September. So the contents, I will finish speaking in a second. Selini Hadji Dimitru from ECOR, which is an operational research network of Italian universities, will give an overview of the project and the hackathon, and then we will have 4 technical presentations on the demonstration of the hypernetwork, and then we'll come back to the practical matters and some questions, and we expect to take 1 hour and a half. So I hand over now to Selini from ECOR, who will do the first presentation. I'll make her presenter.
So, good morning. Can you see my screen? I hope so.
Yes.
So,
you need to share your screen. Yeah, that's it.
Okay, good. Thank you, Andrew, for the presentation. So the objective of this presentation is to give an overview of NeMo and to let you know what we do expect from the NeMo Hackathon and so the work of the participants, and also finally to provide some information on how the hackathon will be held. So, as you know, NeMo is a European Union project, and it aims to tackle a number of challenges related to the electromobility services. More specifically, NeMo aims to develop interoperable and seamless electromobility services. So we know that currently the main problem is there are several services provided by different stakeholders, but the interoperability among them is missing. So there is a need for an IT environment thanks to which it is possible to search existing services, develop new ones, also on top on the existing one. So basically it is missing a common information model that can be used by all stakeholders, and also with using the information of business provided by business partners. And of course, there is a need for more cooperation between the stakeholders and the business partners. So NeMo basically provides a solution to all those challenges. It is a blockchain solution that is hosted by multiple providers. So it is, as said, a distributed and blockchain environment. Thanks to which it is possible to create electromobility services, to deliver services, execute them, and also provide them to all ecosystem partners connected to NeMo. So basically, all participants that are connected to NeMo can share data and information and also services. So in this picture, you can see the blockchain business network that is formed by the partners who provide and who are using the services. So the interaction among the partners is based on a common information model that enables this seamless integration of data and services that are used by the developers and also by the business users. So the NeMo Business Network provides an API and the browser based application for the users to interact with the systems. So, there are the partners at the center of this NeMo Business Network is the partner management, the service storage, so the possibility to where all services can be stored, and the contract management, where it is possible to bring the contracts also and all the relevant business information based on this blockchain solution. Surrounded by this, there are all the NeMo partner systems, for instance, the electromobility service providers, the distribution system operators, the charge point operator, the third-party service providers, such as the automotive companies that can provide services on a business-to-business as well as business-to-customer level. So in this picture, it is show one instance of the NeMo IT environment. It is called NeMo Node, which is hosted and operated in a data center in the cloud of a NeMo partner. So there are several applications, so the actors that interact with NeMo, for instance, by providing or creating the NeMo electromobility applications, which can be mobile applications, in-vehicle applications. Then there are the service developers. They are also interacting with the node, especially with the service creation domain, and in order to create new services and also to register new ones, to find services, existing services in the NeMo hypernetwork, and generate applications or other higher level services. And then finally, on the bottom left, there are the business users that also interact with the system. For instance, by adding contracts or contracting services for other service providers.
Celine, could you switch to full screen mode because we see some of your background things? Presentation mode.
Okay. Just a second. Now I think you don't see anything.
Yes, we see.
I'm not sure. Let me try like this.
Yeah.
Okay. Now? Yeah. Okay, good. So let me go to the slide. Okay. I probably have something else that you are still seeing, but I don't know how to move it. So in this, okay, so in this slide, you can see an example of two NeMo nodes that are hosted by two different data centers, so from by two different partners. So the application, for instance, it is hosted in data centers A on the left and data center B, so the node on the right uses this application. So in this case, there will be a remote invocation of the service, and the service can be found and linked during building time, so it can be linked statically, or it can also be invoked dynamically during runtime. So basically, NeMo provides this distributed IT environment where the partners, the service, and contract informations are stored in a decentralized manner using this blockchain technology, so distributed system. And it allows to the developers to search and use third-party services. It also allows to create new services, electromobility services, and also to deliver them, and also to let the business users to take part in this NeMo open marketplace. But most importantly, NeMo provides these common information models that allows to unify different business objects and also translate them into this common information model. Of course, this help to the development of this digital single European market. So there are already a few services that have been created and available in the NeMo Hyper Network. There is a list in the NeMo Hackathon website. Some services, for instance, the EV driver authentication allows the driver to authenticate using a username and password. Then there is the best charging options that provides a list of charge points in a given area in terms of in terms of their availability or prices. Then there are a couple of virtual sensors that provide probabilities based on historical data. Another set of services that are related to the battery management, such as the adaptive state of charge estimation to optimize the charging strategy based on mobility demand and vehicle characteristics. Then the charging station along route, which provides a list of charging stations given and along the route given the origin and the destination, and services related and data, for instance, those provided by the e-roaming platforms, such as the charge detail records. So what we expect from this hackathon? The idea is to evaluate the NeMo hypernetworks in terms of the facility and possibility to create new services, electromobility services, and of course to deliver them. We would like to see how new existing data or new data can be integrated in this NeMo hypernetwork, but most importantly, we would like to see from external participants how new APIs or for new interoperable services are created, and of course it is very interesting for this NeMo hypernetwork to understand how new horizontal services or are created, or new third-party services can be integrated and used by new developed services. So what we provide this service creation tool, and which of course we expect the participant to use. The participants should also produce the technical files related to the service that is going to be developed, and a repository where all the technical files are collected, and of course to create an API for new interoperable services. And these developed services should be compliant to the common information model, and for this there is a tool that is the data translation tool that should be used. I'm running out of time, I think. Just a brief overview. The participants can be individuals or groups. They should provide their idea by the 3rd of April. The idea should be a short description of the concept. There can be also a picture, and also a short biography of the participant or one member of the team. So the proposal will be evaluated by the jury based on the relevance of the objectives and also the potential to meet the given criteria, which are shown in this slide, but are also available in the hackathon website. So in the second stage, 3 submissions will be selected by the 9th of April, and the 3 finalists will have to deliver their final application by the 27th of May. They can receive also support by NeMo technical partners, so a group of mentors. And then after this final submission, there will be 1 week during which the application can be uploaded in the NeMo Hyper Network and presented during the 13th ITS World European Congress. And finally, there will be a second round of evaluation which will follow, and the final winner will be announced by the 17th of June. So I'm done. So I don't know if there are any questions about this presentation. Otherwise,
there was one question online from Volker Fricker saying, I don't know if this is for you, Selini, or maybe the next presentation, but it was, does the NeMo Common Information Model support the CIM model from IEC 61850 Smart Grid Standard? I think that might be one for later, one of the next presenters. Instead.
Yeah. The technical details are provided in later. I think Marisa has this type of details, so maybe we can keep it for the next presenters.
Okay. So I will. Okay, thanks, Selini. I will be presenter again. Okay, this is the slide I forgot to show last time. So this is the webinar content. So that first part was done by Selini Hadjimadritu. And the next one will be 4 presentations on the demonstration of the hypernetwork. So the next one is by Theodoros Theodoropoulos from ICCS in Athens. It's a project coordinator organization, and he will present service creation and service execution online and the common information models. And
Okay, hello everyone. So this presentation will be mainly around the tools that NeMo provides to developers and all stakeholders in order to, first of all, create new services or interface new services, interface existing services with standardized formats, and of course creating an execution environment which is interoperable and friendly towards client applications. So this presentation comprises of 3 sections: service creation tools, the service execution tools, and last but not least, the common information models, which pretty much provide the world of objects of electromobility that NeMo provides as a base specification that can be used both to create services, interface them, and of course run services. So service creation facilitates the development of electromobility services based on the common information model that we have been discussing. It enables the development of such services enables a service discovery and invocation based on these common information models. We'll see some of the tools that we can use in order to cooperate with the system, and of course to combine services and create the added value applications by orchestrating existing services that are registered within the NeMo network. So the process of creating services within NeMo includes of course, the basic service development, the service description, and most importantly, includes a phase where everyone kind of interfaces the service developed or their existing services that one may have in its cloud environment, legacy services, for example, in a manner which is interoperable and common for the whole set of services that we consider within the electromobility environment. So in order to do so, NeMo has developed a tool, the service creation tool, which is an Eclipse view integrated in the larger NeMo tool suite, and which is available as a Docker image environment. So this way, we have created a portable environment which requires a few dependencies and really easy installation steps in order to build up this environment. And of course, one of the main functionality of this tool is the creation of and the description of services according to the common information model, and specifically the OWL semantic description standardization specification. So as you can see here in this screenshot of the system, we are describing a service with first of all its name, a basic description, the input arguments of the service. So in this case, we have let's say an appointment event, and a e-scooter, a bike, which is an object. So both these objects are common information objects, and they have been properly described within the common information model of NeMo, as you will see in the later section, and which service returns a bicycle planning event, including the routes of a given biking session. To go on into the capabilities of the service creation tool, in addition to, let's say, describing services in the manner that we just saw, we can also search for services. We can search for services through this tool according to their name, according to their description, and of course according to the possible inputs that these services can have and the outputs that these services can have. So this searching query returns in result services that match the description. And of course, the great added value of being able to easily search services is that within NeMo we can combine them so that we can create added value applications. So within the same service creation tool, we have the business process management functionality, which enables to application providers to pretty much combine existing services that are registered within the distributed hyperledger of NeMo to create applications. So, for example, in this case, we have a flow which includes multiple services, microservices registered in NeMo. We have a process which consists of users entering their location, of users searching for charging stations within the given location, for users selecting a given station within a given radius from the charging location, and also a process where bookings are made for a given charging session within this location. So by combining these components, we can easily create flows which comprise the services, the atomic services that we may have, for example, previously described with the service creation tool. To summarize a bit the functionality of this service creation tool, what is pretty much the outcome of this process that the developer has to go through is that the developer can either create a semantic service description file, an OWL file for atomic services. So this is pretty much the identity of a service within the NeMo, based on which a user can make queries and search services or may invoke services. And for the case of composite services that I just showed before, the visual service description file, which pretty much is the description of the process required to execute an application comprising of many small services. So coming now to the actual service execution, which happens once we have created our services. All NeMo services are executed through the common execution portal, which is also referred to as the integration bus. In order to enhance developer friendliness, we have created a Swagger user interface, which helps developers and business partners wanting to integrate existing services or to test the services they have developed in an easier manner. So what you see is pretty much the portal of the Swagger interface. It comprises of 4 web service post HTTP endpoints. There's one generic endpoint which is used to actually get client credentials based on some security tokens that will be awarded to people willing to execute the services. And then the 3 basic functionalities which are the second step after obtaining an access token. Namely, functionality regarding the execution of an atomic service, the execution of a composite service, and a service search. So we'll go through one atomic service execution example in order to see how this Swagger interface looks like. Of course, Swagger is a quite well-known and pretty much used interface by many developers. So we hope that by introducing this flow, people will be able to quickly get the grasp the essential way of working with NeMo. As I said before, in order to execute a service, firstly, one has to obtain an access token. So, of course, this is made by executing a post request towards a NeMo integration bus located within the NeMo node, which Celine detailed in her previous presentation. So within the Swagger interface, you can see the input schema, the parameters required in order to obtain a token, which is of course client ID and client secret, which will be awarded to participants of the hackathon. This flow pretty much follows the OAuth 2 standard of authentication standardization, and in return, what we get from this web service invocation is an output including an access token to further perform the functionality, the 3 basic functionalities that we previously saw. Of course, within the Swagger file, you can see the output schema so that developers know exactly what to accept in terms of the object model of the return. So this access token is then used in the subsequent call to execute a service in this case. And of course, the interface is same for this web service endpoint, and it includes the main input arguments, the input schema, the output schema, and the responses, and some auxiliary views that can help the specification of the actual request that has to be made towards the integration bus of NeMo. So we will zoom a bit into the view of an atomic service invocation to see the details regarding it. So the list of input arguments which are required for every service, for any service call made towards a demo are authentication parameters. So authentication parameters include the parameters which are required by the actual service invoked, and these authentication parameters would pretty much specify the amount of information that has to be exchanged between the actual NeMo integration bus and the service to be called. So, for example, if you have a service that that requires authentication based on OAuth 2, you would have to pretty much tablet input, for example, the OAuth 2 specification type in this entry, the client ID, client secret, and so on. Our documentation regarding the authentication details includes details for your case. Going into the next parameter that is required, the header parameters. In this case is a map of key and values that would regularly comprise the typical header parameters included within an HTTP invocation. The input object common formation model. So this is the basic input arguments for the service to be executed in the common information model JSON format. The path parameters, the query parameters, and the service ID. The service ID is the unique identifier of your service as registered within NeMo. So this service ID field is actually a mandatory field because it is used by NeMo to actually route a service invocation within the hypernetwork to a given service, and other parameters should be used as necessary. Going into a specific example of a service invocation, we have here an example which includes a common formation model object, which is a trip, and which comprises the trip start geocoordinates, the trip end geocoordinates, a user's charge need, and which includes the trip energy need and the email of the request, and the actual service ID, which is in this case the CP list e-roaming service, which is the service that provides a charging station along a given route. This is one of the services actually that Selini introduced during her first presentation. So what you see as a part of the input object is a serialized version of some attributes of the SIM object, which is also a JSON escaped, as this is the way in which we can pass a JSON object within a string when executing the integration bus call. So in return of this actual invocation, what we get is a list of charging stations. Of course, you can see the result in the Swagger. You could be able to see the result in the Swagger interface, and the result is actually a translation output. The notion of translation has to do with the fact that what you see in return is a common information model object, but NeMo goes through the process of translating common information models to clear proprietary formats used for the actual services. And my colleague Marisa will go into the details of this transformation. Yes, what you see here is a JSON object of the list of charging stations, including basic information regarding the maximum power of a charging station, the ID, location info, and so on. Going into the common information model specification that we just saw and that which we used in order to describe a service semantically, and which we use to invoke a service. Obviously, this common information model object models all physical objects and data structures which are relevant to the use cases of the NeMo, of the project. So it covers various span of electromobility use cases. It's based on previous relevant work, and it integrates existing standard information modeling related to electromobility. In a big extent, the common information model is based on the EMI3 specification in the ISO 15118 specification for the actual objects that are described and used in the specification. And obviously, this common information model has been coded into a YAML and JSON format that will be available to everyone through the project portal, so that it can be used to describe services, to execute services, and to map proprietary information models to the common information model of the project. These are the main categories of the common information model. These categories include the electric vehicle, the charging infrastructure, the end user and driver, the charge session, the smart charging functionalities for load management, the marketplace for the marketplace object for service creation and delivery, grid loads, vehicle preparatory condition, and some support business objects, which are objects that may not have to do strictly with electromobility, but which are required in order to include services, for example, for login and log out of users, and kind of auxiliary generic IT services. Going into an example, the common information model is available in YAML and the JSON format. These are two very popular formats. What you see here is an extract of a vehicle object model described in the YAML format. So as we can see here, a vehicle object comprises the vehicle identification number, the manufacturer, the vehicle model, charging mode, max charging power, notification date, the plug type, vehicle event, or the vehicle nominal power, the vehicle nominal range, the vehicle speed, the vehicle odometer, the vehicle state of charge, and so on and so on. Along with, and all these properties are of course described according to their ICT type. And what is important is that these files can be used to generate supporting objects, supporting classes for invocation of the services, and also for semantic description of the services. The common information model is already publicly available on the site of the hackathon, so you can visit this URL. Of course, all this information regarding the various tools that we have seen within the sessions are available also online. And thank you very much for your attention. We will be happy to address your questions or details regarding the process of the participation through email. So don't hesitate to drop a mail to tatheodopoulos@iccs.gr in this case. So thank you very much. Andrew, this is all from my side.
Thank you, Theodoros. So the next presentation will be from Thomas Waltz. We can have some time at the very end of this session for general questions, but you can, I see you're already asking questions online, so I'm pushing those to the speakers where required. So Thomas Waltz will present the marketplace overview. This is a recorded message, so you may need to turn your sound up a little bit. And so we will start that now.
Dear NeMo audience, today in this webinar, Thomas Waltz, myself, and Octavian Safdar want to present you an overview on NeMo Marketplace for Electromobility Services. The webinar will cover 4 topics. The topic is about the marketplace login and an overview on important information such as roles, nodes, partner type, navigation types. The next part will show you how to search for a service with the information on the services, like what the service can be used for, how you can access the service, how the service is described, as well as the information on how you contract such a service. You can use this to build your application or to build a composite service. From the NeMo consortium, once you get selected, you will receive additional information like our NeMo Marketplace user guide, which gives you more precise information on the functionality of the NeMo Marketplace. Dear NeMo audience, so let's start with the NeMo Marketplace introduction and overview. So here you see the NeMo Marketplace landing page. You will get the URL, the IP addresses from the NeMo consortium. Once you have been selected as a NeMo Hackathon participant, you of course need to log on with the user ID and the password. This information you will also get from the NeMo consortium. Once you have logged in, you will reach the NeMo Marketplace Business Partner landing page. On the right upper corner, you see information about the user ID and the role you have been assigned. Here you see my name as I logged in, and you see my role as a technical administrator. You also will be assigned to a user ID, the technical administrator role. This role is a super role, which includes all the other roles, which narrows down the access control, but the technical administrator role will include the role for a business admin, a service developer, a service operator, offering manager, and contract manager. So you could do everything what you need to do for the hackathon to create a service offering, as well as contract services from other partners, so you can build your application or a so-called composite service. Now let's start moving to the left of the screen. On the upper left part, you see IBM and service prosumer. So the first part before the ad is the company, which will be your company name. The second part is the node you get access to. The node most likely will be the node of ICCS. In addition, you see the information about the company functionality you get aside. So the company can either be a service provider or a service consumer, or you can also be a company which provides and consumes services. We call this a so-called service prosumer. Let's go Further down, here you see the 4 tabs. Tab number 1 is about the business partner, which are currently participating in the Hyperledger network in a marketplace. So you see the company of the NeMo consortium. You can click on a company name and you get additional information on the company size, address, persons, and as well as the service and the service offerings this company is providing. You can, by the search field, which is always present below the buttons, narrow down the information. So if you type IBM or some other information, you can down select the shown list, so it's easier for you to navigate. Now, as a hackathon participant, you most likely want to search for services which fits your needs to build an application or to build a so-called composite service. A composite service is a service which is using other service to build a more high sophisticated service. So one option is to go to services. Here you see the complete list of services which are currently offered within a NeMo network. You can narrow down this by providing search criteria through our search information. But let's click here first to the service categories, which is a list of category IDs, which gives you an idea about sorting the services into certain categories and category names. So for example, we have a group of so-called virtual services and other services, so you can use this to narrow down the services in the services tab. So for example, we will type virtual sensors, and here you see the list of virtual sensors. Let's use this service as an example, the adaptive state of charge estimation service. Within this tab, we see information about the service, the name, the service description, that the service is active, which business partner is providing the service, as well as the selected category. Further down, you see information about the so-called specification URL and the semantic description URL. The specification URL is pointing you to information of how you can access the service and the service functionality. For example, this can point to a Slacker, a WSDL file, or a link which is describing your service, for example, as a YAML file. The semantic description URL here is a URL which is a link to so-called OVL or WL file, semantic description file. This file is created by the service creation tool, which is presented in the section of the webinar from our partner TUB in the service creation part. Once you have made up your mind that you want to use the service, you can have a look at the service offerings, how the service is offered. I don't want to make it too complicated, so here is the name and the description of the service, as well as some information on the billing. Further down, we have a list of so-called variants. The service can be offered in various variants. For example, a for free variant, a variant which is charged per call, per month. So it's very flexible how you can offer your service, or in this case, how this offered service can be contracted. So as we only have one variant, we select this for free charge variant. And with the role of a service administrator, as mentioned, you also have the possibility as a contract manager to contract these services. So the service. So let's click this button. It's not grayed out, it's clickable, so you can now contract this service. Here you get additional information about this service and the variant you just selected. Now you can or need to add additional information to identify this, your contract once it has been signed. So give it a contract ID name. Let's call this Hackathon Sample 1. Name S1. Some description for my nice application. You can select when the service should become available for you. This is relevant if you want to limit your bill. So let's say it gets active today and it should be active for a couple of months, let's say end of May. Once you have entered all this information, you see the accept button gets active, and then you can create that contract. It takes a second, and you see that the contract was successfully entered and sent you to your service provider. In this case, the service provider FKA will contact you and give you information, credentials, how you access your service to be integrated into your application. Going back to the marketplace, you can have a look in the contracts which your company has signed, as well as the offerings you are providing. So in this case, under IBM, now I contracted the service from FKA as a so-called buyer. So let's go to the buyer tab. And here you see a set of available contracts. And this is the one we just did. Hackathon Sample 1 for my nice application. And you can see that the contract is active. Of course, there are options to make the contract active, inactive, or suspended based on some contract. Once you have built your service, which may be an atomic service or a composite service, you need to offer this service to others to be consumable by the NeMo Marketplace. So therefore, we go to the NeMo Marketplace landing page, and as, for example, IBM, respective your company name, you can add a service. So for example, here, when you click services, as a technical administrator, you can also add service. Here we prepared a set of services already, and I will show you how this works when you want to add a service. So it's similar. I pre-populated already some data in here. So just click here on Edit Service. You can also go to another service. There is services here. For example, here. We can go for another service, but there is no difference. So here you can see the information you need to enter to provide the service. Service ID, a name, a category, which we mentioned, description, the status, and as well, you have to provide the endpoint of your service and the service specification with URL of your service, including test instructions and semantic description information. Once you have done all this, you can update the field, and then the service will be added. Once you have done this, a translation file needs to be added, and this translation file can only as well be checked here by checking the translation file, and the translation file in this case now is successfully validated. In subsequent webinars, once you have been selected as a Hackathon member, we of course will give you much more technical details on how to create such a translation file as well as more information about all the respective fields which you need to assign to create a service. Thank you very much for listening. Have a nice day. Bye-bye.
Next presentation is by Marisa Kukovini from Singular Logic in Greece, near Athens, and she will present translation transformation with an example. I hand over the presentation to Marisa.
Hello, this is Marisa Kukovini. I will present you a short introduction on data translators and their role and usage within NeMo. Data translators, functioning on the basis of the common information model presented earlier, constitute the main interoperability enablers within NeMo, in that their main role is to transform messages between platform-specific data models reflecting proprietary registered services and the NeMo common information model, so that diverse services within the hypernetwork are represented in a homogeneous manner. Data translators additionally possess some security features. However, such functionality is for the most part seamless, and we have kept it out of scope of the hackathon. In order to achieve the above, the data translator instance deployed at the NeMo node of the service provider owning the service must be configured accordingly, so that this service can be made seamlessly accessible. During this procedure, the data translator is provided with the so-called platform-specific model to common information model mapping, which, expressed through an appropriate XML structure, reflects the exact relationships between the platform-specific data model based on which the service is implemented and the common information model in both semantic and syntactic terms. Based on this information, the data translator then automatically generates the logic required to transform incoming requests and outgoing responses at invocation time. The mapping XML file is generated during service creation time, and this is something that you will also have to do for each new service that you create. As we have not yet implemented a suitable graphical user interface, this configuration currently takes place manually using an XML editor within the Eclipse environment. The output file will then be pushed to the local artifact server where it will be referenced during service registration. Later, at service invocation time, the orchestration of transformation functions specified during configuration will be executed on demand, meaning on each service request and each service response. This step takes place seamlessly without any intervention by the service creator or provider. In the following, we will present the main features of the XML language used for the mapping, demonstrating some simple mapping examples. A feature of the mapping language is that it enables the definition of the correspondences between any platform-specific model and the common information model in a bidirectional way. This means that for each service, a single mapping is defined in such a way that it can be appropriately interpreted to transform responses from platform-specific models to the common information model, but also conversely requests from the common information model to the platform-specific model. Its basic elements are the following. First, we have the source type, which is the platform-specific data type, which will be the source to translate to a corresponding common information model data object. The target type, which will be the common information model data type that will be derived as a result of the current mapping. The operation, an element defining the function that will eventually be used for the transformation, and possibly some condition elements that enable the user to specify conditions that must be applicable to a particular source type in order for the transformation, or in general the mapping specified, to take place. Note that the reverse transformations, meaning from the common information model to the platform-specific model, will be derived automatically by the translator from the same mapping file by reversing source type and target type, and through additional adaptations that will be roughly explained in what follows. Now we will examine these elements in a little more detail. The root of the translation XML file is a mappings element. This in turn consists of a number of mapping elements, and for each mapping element, the user mandatorily specifies the source types and target types we saw above. They both have to be defined as paths so as to indicate the hierarchical locations of the sources and targets. Note here that mappings must be defined down to the leaves of hierarchical structures, and no mapping can be collectively implied. For the source type, the optional attribute data type can be used acquiring the value array in case we need to denote that an array of elements is expected as source rather than a single element. Similarly, the same attribute can be used also for the targets. Here, using this attribute, we mean to show that an array of elements must be created as a result of the particular mapping. From there on, there are two possibilities. Either the operation to be performed on the sources in order to produce the targets is defined, or another mappings element is defined, which will encompass in turn a series of nested mapping elements, denoting this way hierarchical or recursive mapping definitions. In any case, upon reaching the innermost mapping level, the user has to specify the operation. This element, apart from a particular function, will further specify the exact parameters to be used by this function and its exact output among the ones potentially implied as part of the sources and targets through its sub-elements, input and output that we can also see here. Essentially, while sources and targets map fields, inputs and outputs map their values. We currently distinguish between three types of operations. Predefined operations represent basic built-in functions defined through the function element. The user in this case must also declare a reverse function, which is intended to be used for the reverse transformation, in other words, from the common information model to the platform-specific model. For both regular and reverse functions, the user may define a function name and optionally one or more parameters. The function name can currently acquire one among a fixed set of string values that correspond to the built-in functions that we currently make available through the translator. Another operation type is value mappers that define correspondence pairs between different enumerations. We can see the definition of mappers type in the next slide. The mappers element consists of a series of mapper elements that correspond to single platform-specific to common information model value mappings. Each of these pairs defines a source value and a target value. The source value specifies the platform-specific model value, while the latter the corresponding common information model value. Further, mapper selection priority can be specified by the optional attribute priority in order to cover cases where one platform-specific model value can possibly correspond to more than one common information model values and vice versa. Finally, another feature that will, however, be left out in the context of the hackathon is that custom operations are also supported, allowing the user to load the translator with custom transformation functions in order to cover more complex cases. For this type of operations, the string element operation class points to the implementation so that the translator can locate and invoke it when needed. Finally, regarding conditions, the translator currently supports simple conditions that consist of a subject, an operator, and a value. The subject element defines the source of the data that the condition applies to. The value can be essentially of any type, while the operator can be one among some standard operators we have currently defined. For the reverse transformation, the condition element in fact implies that the target type to be created must fulfill the specified constraints. Now we will conclude with two simple translation examples taken from actual NeMo services. The first corresponds to a service request that, according to the common information model, consists in a JSON object called correlation ID that contains the parameter correlation ID, which accepts string values. The resulting platform-specific request must contain just the parameter correlation ID, which must be an integer. The corresponding mapping excerpt is this. We see the platform-specific source type and the target in the common information model. Note that here we have placed a SIM request at the root of the target hierarchy. This is used because essentially we want to translate a JSON object to another JSON object, and we need to be able to reference the input object at the top level by name, which can be real or hypothetical for our purposes, as is in this case. The operation specified makes use of the predefined function value copy, as actually indicated here by the reverse function element, since in this case we translate from the common information model to the platform-specific model. Further, the data type defined for the input implies that upon copying the value while translating from the common information model to the platform-specific model, this must be transformed from a string to an integer. The translator inherently supports such basic type conversions automatically in cases that such thing is needed. The second example shows the response received from a different service. Here, the parameter driver ID, as per the platform-specific model, must be mapped to a parameter called EMA ID contained in the SIM object user. In the mapping, we see again the definition of the source and target hierarchies and the use of the value copy function, this time as declared by the normal function element. That's all from my side for now. More specific examples and details are included in the translation manual that will be provided to you in support of the hackathon, together, of course, with the translation XML schema.
Thank you, Marisa.
Thank you.
So I just share my screen. So next presentation is by Thomas Fous from Girev. So it's an electric vehicle roaming company near Paris, and he will now present an example of an existing service. I hand over to Thomas.
Hello, Andrew.
Presenter.
Okay, thank you.
Presenter.
Okay, do you see my screen? And do you hear me?
Yes, good.
Okay, so now we will see a more concrete example of a NeMo atomic service. So for this example, I took a service provided by Girev to start remotely a charge on a charging point. So on this picture, you have a charging point and a car, and a driver with a mobile application provided by its e-mobility service provider. So in the normal case, Girev provides a service that an e-mobility service provider uses to start remotely a charge on a charging point using the Girev protocol EMIP. Then Girev transfer this request to the charge point operator backend, and the charge point operator sends the remote start to the charging point for at the end charge the vehicle. Now, using NeMo, a NeMo partner will be able to start remotely a charge on the charging point. So for that, the NeMo partner has customers with mobile application provided by this NeMo partner. And the NeMo partner uses a service to start remotely the charge to the NeMo hypernetwork using the common information model. Then the NeMo hypernetwork will make the translation between the common information model language to the Girev proprietary language in order to send a request to Girev, and for at the end charge the vehicle. So if we go to the marketplace, we will see services provided by JREV and the remote start charge service. So we have the name of the service, its description, and some technical information. So like the web service endpoint, so the real endpoint of the service provided by JREV, the WSDLs of this service, the mapping, so for translators, so which translate from CIM to proprietary language, and the opposite from proprietary language to the CIM. And the semantic description, which contains all inputs, outputs, and description of the service that the NeMo partner will use. So if we execute this service, I have created a small program. So here we see the different requests to execute the service. So first, we have the request to get the access token. So here is its URL to get the access token, and the NeMo partner has to give its own client ID. So here it's integration bus JREV, and a client secret that I have anonymized for this presentation. And the NeMo node returns an authorization token that the NeMo partner will use to execute a service, a remote start service. So here is the authorization token returned by the NeMo node. So it's really long. Then we have the remote start charge request. So it's a REST request, really easy and simple. So we have the URL that the NeMo partners will request, execute service client. It's a post request. Here we have the headers with the authorization token that the NeMo partner has got previously. And the body of the request with the service ID, remote start charge, as we have seen in the HMI, in the marketplace. The invocation type, so the service provided by JREV is a SOAP service, and the input parameters in common information model language. So here are the input parameters. So it's an authorization. It's an object that you can see in the common information model. And in the answer, we have the answer of the service, always using the common information model. So we have a return code and an authorization response. So here we see that the service, the return was in success, and the status of the charge is 1. So it means that the remote start was successful, was in success, and the charge has begun. So here we can see so the standard JREV request. So all e-mobility service providers connected directly to JREV have to send requests like this. So it's a proprietary language of JREV, EMIP. And we see the same request using NeMo. So using the common information model, where we have just to put some mandatory data, like the EVSE ID, the charging point, the identifier of the driver, and the ID of the e-mobility service provider. So I'm available if you need more information or if you need help during this hackathon. Thank you.
Merci. Thank you, Thomas. So I take back the screen. So that's the end of the technical presentations. Just a short wrap up of today, because we've got about 10 minutes left. Just a reminder of the timing first. So The first stage, 3rd of April, is really only about 2 pages of offline submission of expressions of interest. So we don't ask people to actually develop or use a service by that date. It's to provide an overview of what they expect to do. Then the steering committee of the NeMo project will judge these on the criteria that Selini showed earlier in the table. It's also on the project website that I will show in a minute. After that, the 3 finalists will be invited to submit developed services to the hackathon email. So for this, they will be given credentials to access a NeMo node, the one that's hosted by ICCS, so they don't have to set up their own node. They will have access to one, and then there will be presentation of these services and apps in the startup area of the ITS European Congress, to which the 3 finalists will be invited if they wish to come, or if they are unable to come, maybe if there's a way that one of us can present their service, then we will do that as well. And then shortly after the Congress, we will announce the winner. I'll show you quickly the page. So nemoemobility.eu/hackathon. All the information is there. It will be updated as time goes on if there are new files. We can also follow us on Twitter and LinkedIn. So this gives a brief overview of all you've seen today, and of course the presentations and webinar recording will be put online here as well. So you see the components and tools, and there are some drop-down boxes such as here, and also links to the user guide and the Swagger interface that Theodoros mentioned. And there's also a previous tutorial which was based on service creation. This took place a year ago, and this webinar is still online, so that provides additional information. You've got the process and the selection criteria here, which Selini showed earlier, the prizes and key dates. So that's the overall the links and so on that they can use. You can use this email address at the bottom, hackathon@nemoemobility.eu, just to either send submission, but any other questions you can send to there. And that is the end. If anyone else wishes to ask a question, what I'll do, I'll unmute everyone because there are not that many people here. So I will. You can either write a question in the question box, or you can speak. If I can.
Do we have something similar here?
So we have some questions here that you can see my screen.
Yeah, but even if you just have to go through a migration to a hackathon, then that's covered.
There's a question from Volker Fricker about the data translation to be used in the hackathon. Is it mandatory to be used or not? I don't know if one of you, maybe Marisa or Theodoros, is able to answer that.
Yes, I can answer. It is mandatory to use the data translator. As I said at the beginning of my presentation, it is the data translator. The configuration of the data translator happens essentially is a two-step process. When a service is created through the Eclipse environment for the creation of the services, the mapping XML file has to be manually specified. Then it is uploaded to the local node, to the local NeMo node, and from there it can be referenced later upon the registration of the service. This takes place through the marketplace, the NeMo delivery environment, The details of this procedure are described in the manuals that will be distributed, but to put it briefly, upon registering a new service, the user has to provide the URL of the location of where the mapping file resides, and then has to click on a translation button, and this will trigger the configuration of the translator. So briefly, we would say that the first step is to create the translator mapping file, and then to use this mapping file through the graphical user interface provided in the marketplace in order to configure the translator and to be able to offer the service.
Okay.
I don't know if this is clear, or if somebody would additionally demonstrate something right now in the marketplace, but it is described in detail in the manual.
Okay, thank you, Marisa. Are there any other questions, either vocal or online? I think I have unmuted everyone, so if you cannot speak, then I think you've muted yourself. Of course, you can give I just tried to unmute Thomas Waltz. He wishes to say something, and I think
now it works.
Thomas, you can
Thank
speak.
you,
Sorry,
Andrew.
you were on there twice, and I unmuted one of you, so not the other. You can speak.
No problem. Yeah, Christina, maybe you will answer the question for Volker, or I can do it. The question from Volker was whether a hackathon participants, once selected, need to install a NeMo node by himself. The answer is no. The plan is to give, once selected, access to an existing NeMo node as a so-called affiliated partner. So you don't need to install a node. Okay, Volker, did you get it? Or yeah.
Yeah.
Okay.
Thank
so
you.
we don't want you to have to install a node. This is quite some work, and also implicates that you get into the blockchain network. So we want to make it easier. Therefore, we introduce a so-called affiliated partner, and the hackathon companies will become an affiliated partner of the ICCS node. But you will get the details once you get selected. Okay.
Okay, thank you, Thomas. Any further questions or comments? We are pretty much on time now to finish. No. So I just remind you to keep up to date on the NeMo website and follow our social media, and please feel free to pass on the link to that website to other people that you know who you think might be interested in taking part in this hackathon, because I know it's sometimes a challenge to reach developers who are not part of our immediate network. So please disseminate as widely as possible. And please, any other questions, you're welcome to send to the general email there at the bottom of this page that you can see. Okay, thank you very much, and we'll close the webinar if there are no more comments. Thank you for participating, and have a good day.